Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with time series modeling. In the last lecture, we have discussed this component, that to knowing the understanding of time series data and what kind of models we like to use under the time series umbrella. Here some of the engineering problems can be solved, or we can do the predictions, do the kind of forecastings. Different types of models, time series models we can use, but one of the requirement is that data structure must be with respect to time only. It may be annually, it may be day wise, it may be monthly, it may be quarterly. So, that means having the data with respect to time. So, we like to do the prediction. Of course, different types of models can give different kind of setup and structure through which you can do better and better kind of modeling, and that too the way of or the kind of requirements of forecasting or the kind of prediction. So, let us see what are the kind of structure we like to discuss, and of course, last class we we have spent couple of time to understand the time series data and slightly touch upon various issues of the time series data. Typically we have discussed about the kind of variation in the time series data. So, over the time it cannot be stagnant. So, it will having upswing or downswing. That is why we have discussed various factors responsible for this change. So, that means if we start with a particular number, so the number may not constant. So, it will go up or it will go down, and for that we have discussed 4 different causes, that is regarding secular trend, seasonal variation, and maybe due to cyclical variations and irregular variations. So, that means data over the time may change that too with respect to either the structure of secular trend, or with respect to seasonal variations, or with respect to cyclical fluctuations and the kind of irregular pattern. So, we have already discussed all these things in the last lecture, and if you look here, and all together a time series data at a particular point of time involves many things. So, that means technically, so means the time series data may be like this, y t, then y t plus 1, then y t plus 2. So, this is actually forward movement, and then y t minus 1, y t minus 2, and this is called as a backward movement. So, that means technically we expect that these are all not equals. So, these data are having different over the time. So, that means if you say here 10, then this may be 9 and this may be 8, this may be 11, this may be 12. Just I am giving the kind of structure, not exactly the 11s, or the kind of movement may not be actually completely upswing or completely downswing. So, it may be kind of non-linear in characters, like sometimes up, then slightly down, again down and slightly up, like this. So, all these variations with mostly with respect to these factors, the cyclical structure, then seasonal structure, irregular structure, like we may have any kind of structure. So, ultimately, so 4 factors which you have identified, T, S, C and I. So, now at a particular point of time the variation of the data that is with respect to all these 4 component T, S, C, I. So, ultimately they will be linked either in a additive format or in a kind of multiplicative format. So, that is why it is called as addition models or multiplication model. So, that means just y equal to t plus s plus c plus I. T stands for trend value, S stands for seasonal fluctuation, C stands for cyclical fluctuation, and I stands for irregular fluctuation. And in the multiplicative mechanisms, so it's simply actually you have to multiply each other. So, that means it's a kind of additive model, and otherwise you can say that multiplicative model. So, there are two different ways the variation can happen here. So, ultimately the idea is that to check whether data is actually varying with respect to time, and if that is the case, what are the factors responsible for that. And in the first instance, we expect that the variation is mostly due to these 4 factors: trend factors, seasonal factors, cyclical factors, and irregular factors. So, now after understanding the kind of variations, so let us see how is the kind of time series model. Ultimately we need to do some kind of forecastings, and the beauty of this forecasting I have already mentioned here. So, we have actually historical data, and means the time series data, otherwise called as historical data, since it maintains consistency. So, we have historical data from from the left or from the past, and then with the help of this left and past data we have to trend for the futures. That is what the structure called as predictions and forecasting. In fact, in the cross sectional type of model, we use the data, then have the estimated models, then you check the estimated model. If it is okay, then you have to just extend this estimated model for the kind of forecasting. The same structure we are doing here, but the particular prediction and particular forecasting, the kind of extension is much easier and very easy to understand in the case of time series data. Means just enter the data, you just pull the kind of informations, then you will find some kind of trend lines or something like that. By default you will get some kind of predicted line, even without using any kind of standard technique. In totals, there are 4 mechanisms through which you can actually predict the particular engineering problem, and that too with the help of time series data. So, first one is the freehand curve methods, that is the first mechanism, and then the second one is the semi moving average, and then the third one is the moving average, and then least square methods. So, there are 4 mechanisms. So, first one is the freehand curve, semi average, then moving average, and least square mechanisms, out of which least square mechanism is the best. Of course, the way we have written here, freehand, semi average, moving average, and least square, these are all something called as better and better way of doing the forecasting, that too with the help of time series data. So, let us first go one by one, and that means technically how we do the prediction with the time series data by using freehand curve. Again do the means how to predict the variables with respect to time series data, that too with the semi average methods, and again by the moving average methods, and then finally with respect to least square methods. So, let us see how is this particular structure. And so, first we start with freehand curve methods. It is actually very simple one, and just to graphically means it is a kind of inspection method through which you actually observe and draw a kind of predicted line. For instance, so we have actually early data here. So, let us start with 1989 to say 1996. It may be any forms, just I am taking few time series data, and this time series data is the annual data, and starting with 1989 and ending with 1996. So, that means you see here 1989, 90, 91, 92, 93, 94, 95, 96, and then it will go up to say 97, 98. So, it will continue up to, it is a long series data, but just we are giving a samples with how much first few points only, that is with respect to 1989 to 1996. So, we have actually data up to 2017, but for simplicity we just taking a few data, and then this time series focus with the profit data. So, that means it is the industry profit data, and for a particular industry, and that too from the that is with respect to time, and that too from 1989 to 2017. And for instance, 1989 the profit is 148, that too in 1000, then again 1990 149, and then 149.5. So, there is a little bit variations. So, now if you plot this actually data with respect to time, then you will find there is a kind of fluctuation, because they are not constant. So, they are varying, sometimes increasing, sometimes decreasing. So, with this particular variations, so how we can actually draw a predicted line. So, just go through, it is a graphical mechanism through which you can. So, you see here there are two lines, and one is the dotted line, and that is what the kind of predicted lines, and the green line, that is actually the kind of actual data. You will see the actual data is actually slightly deviating, little bit more deviation, and then the dotted line is the predicted line, that is otherwise called as trend line. So, what will you do actually? So, after knowing like this without any evidence, I can plot a line like this. Okay, let us say the movement is like this. So, so if you say that freehand curve fitting, that means you just draw by judgment that this could be the predicted line. So, that means usually the predicted line will be in between all these average points. So, that means you check the peak this sides and the downside peaks. So, once you know the peak up and down, so the predicted line by inspections should be in between actually. So, this could be the very simple trend line. So, means that is the trend line through which you can actually predict the profit here, and that with the available of this much of samples. So, if you increase the sample size again one after another, then the prediction structure will be much more attractive again. Have more data to know the clear picture, but to whatever it is a small data or big data, it is not a big deal. So, what will you do in this kind of mechanism? So, you check the highest point and the lowest point, and then few other peaks in the upside and downside. Then after checking all these peaks upside and downsides, then you draw a line in between, and that's what they call as freehand curve, and that is the curve through which you can do the forecasting. So, this is a simple mechanism through which you can actually draw generate a predictive line. Then second one is the semi average mechanism. So, like freehand curve. So, we have the data similarly from let us say 1991 to 2008, and then how you can apply the semi average data, that too again to predict the kind of structure. And here the same data which we have used for the freehand curve, again we are using for the kind of semi average mechanisms. In the semi average mechanism, most of the instances we divide the data into two equal parts, and if the data is actually having even numbers, let us say 10 data points, then the first 5 points and the last 5 points is the first step process to identify. And so, the first point in this case we have actually 8 data points. So, that means technically, so the structure moving average will be like this. So, 1, 2, 3, 4, that is the one set, then the remaining 4 will be the second set. So, what is the semi averaging method? the first half you take the average, and then second half you take the average. If it is even number, then it is very easy to do that, and if not, let us say if it is a odd series, like let us say a 9 or 11, something like that. So, then from the actually left hand side you take 50%, and then the remaining 50% will be in the right side. For odd numbers, particularly for let us say the figure 9. So, then first 4 points and the last 4 point, then the middle one should be remain silent. For instance, the fifth number should be silent, then you have series from 1 to 4, then 6 to 9. So, what you like to do here? So, first 4 you take the average, and last 4 you take the average, and then you just join the 2 points. That will be the trend line or the predicted line, and what we call as forecasted line. Like the freehand curve, where our target is to check which one is the top point and which one is the bottom point, and then draw the line in between. So, that is how the inspection through which you have to draw the curve, and again little bit what we can call as logically establish or something more accurate, where divide the data into 2 parts, then take the average and take the average and join, and then in between you can have actual plotting, and then the kind of if you join these 2 points, then this will give you some kind of predicted line. So, now what we can do here is whether the prediction is actually accurate or not accurate. So, we can find out the forecasting error, which is actually the difference between the predicted lines and the actual lines. So, if the difference will be more or less very small, then the kind of predicted lines, whether it is a freehand curve or something kind of semi average mechanisms, it is not an issue. That lines can be used for the prediction and forecasting. So, that is the second mechanism through which you can do the prediction, and again the similar structure we can have here. So, that means you see here whatever I have told you. So, just you put in the kind of you transpose the data, then it will be in a particular order form like this. So, this is the first point and take the average here, and these are the last 4 points and take the average. So, now you go through plotting 1989 to 1996, that is in the x axis, and in the y axis. So, you just take the point 151 point, and then you take 155 point, and then just join this 2 points, see here. So, this is what the kind of game. So, you do the actual plotting first, and then you find out where is the point actually 151.50. For instance, here 150, and then what will you do? So, you just check 151.50 here, then again so 155.25. So, you just check it here, then with these 2 points you can just extend this line, and you will find there is a kind of difference, and the predicted line will be very effective to draw the conclusion here. Of course, the issue is that whether the particular line is very perfect to predict, that we can judge through the forecasting error, which we discuss in the forthcoming lecture. But in the meantime, this is the procedure through which you can get the trend lines or predicted line through the semi average mechanisms. So, now move to another structure called as moving average. So, this is a relative concept, and we can have a several kind of lines through different moving average mechanisms. So, you can means for examples, we can have a 3 years moving average, 5 years moving average, 7 years moving average, 9 years moving average. That means, actually the entire data we will put some kind of normalization. So, instead of using actual data, you have to actually normalize that to standardize it. Some way you can standardize the data, like time series has such a beauty actually to do that. For instance, if you are saying that we have weekly data, so then 1 week is nothing but actually 7 days. So, the 7 days data will be fluctuates, but if you take the average, and the fluctuation will be little bit normalized. So, that means first 7 days it will be one figure, then second 7 days there is another figure, third 7 days then another figure. So, then it the way we are saying that first 4 points and last 4 points. So, here let us assume that 7 into 7 49 data points. So, first 7 points take the average, second 7 points take the average. So, likewise you have 7 different points and then you join this 7 different points, and of course there is a very I mean say you will get a standard line to predict the kind of requirement and forecast the kind of requirement. Of course and there are two ways here. If you compare with the semi average and moving average, in the case of semi average, just the entire data you will divide two parts, and then you just draw these 2 points, means connect these 2 points and you will get the predicted line. But here the process is slightly complex and not exactly just to join the 2 points, but here what is happening. So, you are taking you are dividing the data into few clusters, like we have discussed earlier the dummy modeling. So, one type of modeling is actually where probability value will be only 0 and 1, and there are models where the probability value will be in between 0 and 1. So, this is also similar kind of case. So, in the case of semi average, the entire data will be simply transfer into 2 different parts and then take the average and join these 2 points to get the predicted line. But moving average mechanisms, so the entire data will be generated into few points, instead of 2 it will be couple of points in between, and then you join these couple of points and you will get the predicted line. So, we have here starting is the 3 years moving average. So, the structure will be like this. So, what will you do? So, let us assume that this is the first data point, second data point, third data point, fourth data point. So, if it is 3 year moving average, then first 3 will be one average, then again 2, 3, 4 another average, then 3, 4, 5 another average, then 4, 5, 6 another average, then 5, 6, 7 another. So, likewise you will have a kind of chain actually. So, instead of having actually actual data, so now you have the average data where each starting with the first one. So, every 3 items will be transferred into 1. So, that is the average value you are putting, and then you are just joining these average points. Once you do that, then you will find a line, and that is what they call as trend line and the predicted line. So, that is what the mechanism called as moving average mechanism. And of course, it is not necessarily every time the moving average will be with respect to 3 years only, or 3 time periods, not exactly year wise data, it may be weekly. So, week wise data 3 days you can create a kind of structure, again another 3 weeks or 3 days you can create a kind of structure. So, means ultimately it is the time series data, no specification whether it is annual or monthly or quarterly or day. So, whatever may be the form of data. So, while doing moving average, that to 3 years moving average, just to start with the first and then follow every 3 point is the average, and then you join these average. So, when you are just transferring the data every 3 into 1. So, we have no business with the data structure, that to whether it is day wise informations or hour wise informations or the kind of course, that understanding will be there definitely. Otherwise, you may not do the kind of time series modeling. Once you have the record, then after that the process the process which you like to do will have no connection with this kind of structuring. So, likewise, so we have a different kind of setup. So, likewise we can go for 5 years moving average. So, instead of 3 points, so we take first 5, then second 5, that starting with second data points to 6 data points, and go ahead with all these possibilities. Then finally, you join these average, you will get the average lines and the predicted line through which you can do the predictions. So, like this. So, we will just transpose the data. So, now this is the actual data here, and starting with let us say 1982 to 1996, and we have a price of sugar data, that is the original, and then we have here predicted data, and that too with 3 years moving average, and this is with respect to 5 years moving average. Then you can go for 7 years moving average, and so on. There is such a hard and fast rule. Only thing is you should know how we can have this average figures. So, that means here if it is 3 year moving average, then the first 3 will give you this ones, then the second 3 will give you this one. So, this is how the kind of structure which you like to follow, and what is happening here. So, what we do means in this particular tables. So, we are just adding these first 3 data points down, then take the average, and then you will draw the kind of lines. So, it is not actually big deal how to do this. So, after doing this, then you just join the point, and you will find a predicted line, and that predicted lines will be used for kind of forecasting, right. So, then then the method is called as least square method. So, that means technically there are 4 standard methods through which you can actually do the first hand prediction through the time series data. Of course, there are lots of hardcore models like ARIMA models, then Arch models, Gach models, Bahar models. So, these are top class models in the time series circle, but in the first instance having the time series data, and these are the simple methods or mechanisms through which actually you can do the predictions and then do the forecasting as per the kind of engineering requirement. So, that means technically in the first instance the simple mechanisms will be by by freehand curve, then semi average mechanism and moving average mechanism, and the least square methods. We have already solved the problems through the kind of semi average and the moving average and the kind of freehand curve. So, we get to know that how is this particular structure. Of course, every you have the kind of an option to compare and check which one is the best, and then finally pick up. But method mechanically, if you start with freehand curve to the semi average and moving average and least square methods. So, as per experience is concerned or literature is concerned, so the all these methods are systematically improved versions. So, that means the prediction will be by least square method is slightly better than the moving average, and prediction by moving average is better than semi average, and prediction with the semi average is substantially better than the freehand curve. So, that means it is a degree of improvement over the time. So, till now we have discussed the freehand curve, semi average methods and moving average methods. Under moving average methods we have a different forms like 3 years, 5 years and 7 years, and then we know how we can do the predictions, and that too with the availability of time series data only. So, when we are actually doing the moving average, so since data are very consistent with the time, we can do this average and then do the predicted line. But if it is cross sectional data, which is not very easy to do the similar kind of prediction, and that is what the beauty of this time series modeling. And the last one is the least square method, which we will discuss in the next class. With this we will stop here. Thank you very much.